Have your calculators ready for this one, your graphing calculators, because we're gonna need them, okay? So I'm gonna highlight that just to make sure you know we covered it, okay? So graphing a system just means more than one. That's all it means, okay? You can't see that, right? But systems just means more than one inequality. So we proceed the same way as before, but now you have multiple inequalities on the same pane, each with their own solution panes. You must work with each IQ separately, so you don't mix up your solution. Okay, I think you would all agree with that, especially as we go along. Shading systems. Having multiple solution regions makes it difficult to determine the solution region, because we're going to end up having just one solution region that all of the inequalities share. Okay, so to make it easier to determine the overall solution region, we will use reverse shading with systems. I want you to highlight that part. I'm now switching gears and I'm going to go reverse shading with systems. And this is why. I wanted you to understand why it is that I'm doing that. So here are two systems. They're the exact same system. If you use regular shading, it's the darkest region that ends up being the solution system for all inequalities present. The computer does a pretty good job at it, but us, if we just shade our way, it's going to be almost impossible to figure out which one is the darkest region. It's going to be very, very hard. Okay. So that's why I use reverse shading, because what ends up happening if you shade all the false regions, you end up with your solution region being like the one that they all share is the one that's not shaded. So it's super easy. It's like, this is it, right? So that's why I use reverse shading. It used to be a nightmare, to be honest. Like, it's like, which one is the darkest? Because right, like you're not so consistent with your shading, and so you're like, what? So this is right in here, solution region. This is the true region for all of them. Okay. So I will just say this under the reverse shading. Shading all false regions, right? False regions leaves the solution unshaded. Easier to see. That's basically why I do that. So the textbook doesn't do reverse shading because the answer key at the back of your textbook will always be a nice computerized graph. And actually they do colors, right? They do red, blue, green. And so you obviously can see, okay, this is the region that is the one. We don't have the luxury of that, okay? So I hope you understand. Reverse shading is just to make it easier to see, okay? Basically, it's just to make it easier to see. We're on page 29, Xander. We're going to graph systems of inequalities. It's basically to make it easier to see. Please remember that. So that's point number one I want to make before I start. Point number two, it's literally points, right? Points of intersections. I call them POIs or corner points. They mean the same thing. I will say I want to highlight this. The points where boundary lines meet and surround the solution region of the system. So in this particular case, this is my solution. You can just go SLN like that, SOLN solution. In this case, you have 1, 2, 3 points of intersections, 3 POIs. By the way, guys, when some students make the point where it crosses the intercept, like the x-intercept, y-intercept, as part of the POIs, they are not the POIs, okay? Points of intersections are just where lines meet, like actual lines that you've graphed, okay? In this case, there are 2 inequalities here. So there's only 1 POI, okay? This is my solution here. Only 1 POI. I will say this point right here and this point right there, not POIs, just intercepts. So keep that in mind as we go along. And the inequality region may not always be a triangle. It could have different shapes. Okay. In this case, it's not closed here on the bottom side. It actually keeps on expanding indefinitely. Okay. So let's keep going. 29. And now we're going to 30. So here's the meat and potatoes of today's lesson, okay? Graph the following system of inequalities. Then identify the solution region on the graph. Include the POIs. It is a good idea to graph all lines on the calculator before graphing it on paper, since the POIs might be outside the grid. And I will highlight that part. Before going on paper, it's a good idea to just once enter them into your calculator and see what do they look like? What does this look like when I graph it? Where do they meet? Where do these lines meet? And I think you would all agree that this looks a little scary. But this is just, this is the formal way of introducing an inequality. What variables are present, x and y? This is the actual inequality. Let's highlight the inequality itself. That one right there. And then it's just telling you that x and y, they're both part of the real numbers, which means x and y could be anything. It could be decimals, fractions, negative, positive, you name it, right? Which has been the case for all of our questions so far. Same thing with the second one. Introducing the variables. And then, because I could use z and m if I wanted to. Standard is x and y. And then x and y are both part of the real numbers. But we just focus on that part right here. So don't let that scare you off. Okay? So what I'm going to do is I'm going to call this 1 and this one 2, my 2 inequalities there. And just pretend like you're doing one at a time. So what we did yesterday, I'm just going to do one and then the other. So let's take our first one here. You got to be wise with your space. I'm going to write out that inequality and slightly rewrite it already because I don't like it the way it is here. 4x, I'm going to make the 6y come over. You're looking up here, right? The 6y is coming over to this side. Okay, so minus 6y. And then I'm going to go greater than 12. That's how I like it. That's how I would like it to look like right from the beginning. Okay. After this, let's find the intercepts. X-intercept, Y-intercept. And remember, for this particular moment, you make that an equal sign. The inequality is turned into an equal sign because you want that boundary line in this case. So x-intercept y is equal to 0, so just 4x is equal to 12. Divide both sides by 4, x is equal to 3. You end up with 3, 0 as your x-intercept for this particular line, the boundary line that is part of our inequality. Y-intercept, x is equal to 0, so you end up with negative 6y is equal to 12. So y is equal to negative 2. Negative 2, that is, right? 0, negative 2 is my y-intercept. Boom. Let's box that in nice and compact. There we go. And now we rewrite it because we need to enter this into our calculator at some point. So I take this one here and I just go, how about I do this because these are your notes, I'm going to rewrite that exactly as I have it up top. And I'm just going to start rewriting it. Negative 6y is greater than, remember nothing flips here when you're just bringing terms over. Okay, 4x comes over negative 4x. The 12 is already there. So just keep the sign. So in this case, it's positive 12. Then I'm going to divide by negative 6. And that should be a warning to you. Do you remember what happens when you divide by negative? You at least nod, right? It's like, yeah, I know. I totally know, Mr. Dixon. As I'm scrolling down on my feed here, right? So y flip, right? I'm going to maybe use a red pen to emphasize. I'm going to make it look, I'm going to turn it the other way. And it's very important. It makes a big difference. And then negative 4 divided by negative 6 is just 4 over 6, correct? X. 12 divided by negative 6 is negative 2, which jives with the intercept, the y-intercept that I just calculated. So we're good. It's going to be dashed. The true region, maybe for now we'll actually write it out and then later on we won't anymore. True region is below, correct? Just not. It would have been above if you hadn't flipped the sign. So that's why it's important to flip the sign when you divide by negative. And watch this. I want you to all have this part, be ready for this part, because this is against what we've been doing so far. True is below, but if I use reverse shading, I will shade above. I will do the opposite. So shade above. And I will, for you, just for you here, reverse shading. Mr. Dixon, why are you doing reverse shading? Because it's a system. So what? It's easier to find your ultimate solution region if you do it that way. So I'm gonna, before I start shading, I'm gonna come here and look at this. This is what I'm gonna go by. Because let me tell you, if you have 2 or 3 going, you don't want to every time have to rethink it. You want to think about it now, write it down, and then move on. Okay? Okay, we're ready for the next one. Let me see. I want to have everything on there so you can still copy if you're behind. I'm going to do the second one here. So I'm already going to shift it a little bit. If you look at it, the x is over on the right side. So I'm going to bring it over positive. The 3y is already there. And this is a less than or equal to 9. Okay. Then I'm going to find my intercepts. And so it's 2x is equal to 9. Divide everything by 2. X is equal to 4.5. Not a big deal. So when you find your intercepts, it's okay to round. Okay? intercepts is okay to round. Is this your slope? I would like you to keep it as a fraction because sometimes it's repeated decimals. I want you to keep it all. And then the next one is, slow down, Mr. Dirksen. Still writing this down. Slowing down. For my y-intercept, this turns to 0, so it's 3y is equal to 9. Divide everything by 3. Y is equal to 3, 0, 3. Boom. We're done that. Okay, let's rewrite it maybe over here because we've got space. Write it into y equals mx plus b form. That's what I mean. So 3y is less than or equal to, this 2x comes over to the other side, negative, plus 9. Divide everything by 3. Do I need to flip the sign? No. Why not, Mr. Jackson? Because it's not a negative that I'm dividing by. Okay. Negative 2/3 plus 3. Okay, solid. True region is, it's less than, so that means it's below. That means I have to shade above. So you're going to have the shading being always opposite to where your true region is. Okay? However, the true region is where it's at, right? Like that's ultimately what we're after, but we're going to shade out the false regions. Let's go ahead and enter this into our calculators. So by that, I mean this one here and this one here, like the both rewritten forms. We have to treat it as if it's an equation. So turn on your calculators. I'm going to go to y equals. Whoa, what's that? Anyways, I'm going to clear all that. Make sure your plots are turned off because you're not doing a regression. You may have used it for reviewing purposes, right? But you're not doing a regression. That should all be nothing should be highlighted. And let's enter it. So I go bracket 4 divided by 6, x minus 2. And then I'll do the second one here. Bracket, you got to use the negative button, not the minus. Right? Negative 2/3 x plus 3. I have no idea what my window is like, so I'm just going to go ahead and graph. My window is pretty good. But let's all have the same window, so we're going to go zoom 6. Zoom 6 is just your standard window, 10 in each direction. It works out perfectly, right? So why I mean you should graph this is just to make sure, in this case, I know for sure it fits into a 10 by 10 window, right? 10 going in each direction. So it's perfect. So I'm just going to leave it there for now. Put this back on the side. And now we're going to start graphing. Because sometimes the POI may be way out here if you just stick to a scale of 1 based on the grid you have, okay? So sometimes, oh, my POI is way over here at like negative 15. I need to adjust accordingly, right? I need to make every tick be worth 2 or something like that. Okay, so let's start here. X and Y. Don't forget about that. Sometimes I'll ask you to do it from scratch. A scale of 1 is pretty good. I should say, let's make sure we mark where we're putting those numbers, right? There we go. Let's do the first one. 3, 0, 0, negative 2. And that is a dashed line. So we're going to go like that and dash it. And at the end of it, either end, I'm going to already label it whichever one you want. I don't care. So I'm labeling my inequality at the bottom here at the end of it. Otherwise, it tends to be in the way if you do it somewhere in the grid. Don't shade yet. Okay, just do the other one. 4.5. 4.5 is right here, and it's 0.3, right? And the slope is negative, right, on my rewritten. So I do expect it to drop from left to right. This is a solid line. Go back up and just read, right? It's solid. So connect those two. Go extend it across the whole grid. Okay, don't be scared. And then we go y is less than or equal to negative 2/3 x plus 3. Just by looking at the inequality, you should know it should be a solid. Just by looking at the other inequality, you should see, yeah, it should be dashed, right? So you should catch that. And we're getting there. I'm just going to get through this, and that's going to be it for today. So let's shade now. Okay. So I go to my first inequality, which is labeled. It's telling me to shade above, right? You read and it says shade above. So I go to put my ruler there. And I'm saying all of this is really what I'm saying. All of this, get rid of it. It's all false. This is canceling everything. Okay, so that's all gone. That's not applicable. I cannot use that pane, right? And then you go to the next one. What does it say there? The other one also tells me to shade above the line. Okay, so I go to my next inequality, the boundary line for that inequality, line it up like that and just shade above. It's fun, isn't it? Yay, back to it. Okay, so you've now told me, you've told like all of that is not applicable, is not a solution. So what's left is a solution because we shaded out the false. Okay, so you put solution here. The non-shaded part is my solution because as long as you tell me that, we're in business, right? Doesn't matter where you shade it. I actually care more about the solution. So if you're a rebel and you're like, I'm going to stick to regular, Mr. Dirksen, I don't care. If you want to do it that way, as long as you tell me which the solution region is and it jives with what I got, we're good. But don't be a rebel. Just do it. It's not gonna turn out good if you, at least in my experience. So now we need to find the POI. When there's a system, there are POIs. In this case, there's only one. Okay, I'm gonna make a red dot there with my pen or something that sticks out. That one I want to state it here on the side, or you can do it on the graph. It's up to you. So you have this graph. So we're just gonna go second, trace, intersect, enter, 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 and there it is. POI is 3.75, 0.5. Later on, when we do word problems, we may need to round, but this is not a word problem, right? Real numbers. You could have everything. So I'm just going to write that down on the side here. 3.75, 0.5. That's it. So this would be, in terms of the graphing part, this is it. I would just like to this one is always, I throw it in here and there, and I need you to show it mathematically. So let's do this real quick. Is 4, 5 a solution to the system? Where is 4, 5, guys? 4, 5 is over here. We know it's not a solution, right? We can just see it's not a solution, duh, right? But if you don't have a graph, you have to show it algebraically. So what I do is I take this one, for example, and I take the other one, 3y, because I most likely will not have a graph when I ask you a question like this. So what you need to do is you need to plug in the x and y values and see if the statement is true. It has to be true for both of them. Okay, so let's try the first one. 4 times 4 is, wait. This is a y here, guys, the 6y. Can you please fix that? So 4, 4, and then 6, 5 plus 12. That's 16 is greater than 30 plus 12. 16 is greater than 42. Is that true? That's false. Technically, you're done. This is not a solution to the system. But I'm going to still do it with the other one just for fun, because it's so much fun, isn't it? Negative 2, 4 plus 9. This is 15. This is negative 8 plus 9. 15 is less than or equal to 1. That's also false. Therefore, not a solution. I'm going to re-emphasize that tomorrow. But honestly, you could have stopped after the first false. You're done. Because for this to be a solution to the system, it has to be true for both of them. If there had been 3 inequalities, it has to be true for all 3 of them. Okay? So, thank you guys. As always, you were awesome. 31 to 33, practice this. I will have graphing inequalities and writing inequalities on tomorrow's AC, so be prepared for that, right?